come up with the third part of the language of chemistry, and I hope you have been going through the previous two videos well, and you must have understood the various basic concepts which we had discussed in the last two videos. So let us start from where we had left, right? So I think by now your idea about the radical is quite clear, okay? So radical is nothing but an ion. Let us come to the radicals. Radicals are nothing but the charged atoms which I was discussing in the last two classes, that is ions. Clear? And there are two types of radicals. We have the simple radical and the complex radical. Also termed as the polyatomic ion. Okay, this is one way of classifying the radicals. Simple radical means what? It is made up of atoms of only one kind. Like you have read Cl minus, O minus, O2 minus, like that. So it is made up of what? Atoms of only one kind. Clear? Like nitride, atom of only one kind. So this is what? Simple radical. Now what about complex radical or compound radical? You must have read about the carbonate ion, nitrate, yes, phosphate. So like that, whatever radicals are composed of more than one type of atoms. Like in your new classes you have been learning about thiosulfate, zincate. Okay, so these are what? These are the polyatomic ions or the compound radicals or the complex radicals which are composed of atoms of more than one kind. Like this is what? Simple one, because it is composed of atom of only one kind. And this is compound because you can see a carbonate is composed of one atom of carbon and 3 atoms of oxygen. Likewise phosphate, 1 atom of phosphorus and 4 atoms of oxygen. Thiosulfate, 2 atoms of sulfur and 3 atoms of oxygen. So these are what termed as compound radical. Apart from that, you have come across the basic radical and the acid radical. Okay, see, whenever you write the name of a compound, already we have discussed in the last class, whenever, like the compound we took in the last class was potassium chloride. Yes, this is a compound. This is one molecule of potassium chloride composed of 1 atom of potassium and 1 atom of chlorine. It was formed by the combination of the K plus ion and the Cl minus ion. So potassium is a radical, chlorine is a radical here. Okay, it is now called as chloride. Okay, so in the compound we name it as chloride. So chlorine is a radical and potassium is a radical here. So chlorine, so this potassium is actually a simple radical here. It is made up of only potassium atoms. Chlorine also is a simple radical because it is made up of what? Only chlorine atoms. Apart from that, now if you consider this, the formation of potassium chloride, it is a salt. It is a salt. Potassium chloride is basically what? A salt. We call it a salt in chemistry. I will come into the topic of salt, acid and base also. We'll be clearing your some uncleared concepts very soon. So just consider the example of potassium chloride composed of potassium and chlorine. Okay, so potassium is the positive, electropositive. Electrically it is charged as positive, so it is also called as electropositive radical. Chloride is the electronegative radical. Now, how is this salt formed? You know that a salt is formed when an acid reacts with base. And that reaction is called as what? Neutralization reaction. So let us take the example of potassium hydroxide, a base, reacting with the acid, hydrochloric acid, to form the salt, potassium chloride, and giving out water also. Okay, so this is basically, you have read that, and when a base reacts with acid, it forms salt plus water, and this type of reaction is called as what? Neutralization reaction. Yes, you know it very well. So now you can see the salt potassium chloride. In the salt potassium chloride, the potassium is contributed by the base potassium hydroxide, and Cl is contributed by the acid hydrochloric acid. So we can say that in the compound potassium chloride, potassium is the basic radical and chloride is the acid radical. Potassium is the basic radical because it is contributed by the base, that is, in this case it is potassium hydroxide, and chloride is the acid radical because it is contributed by the acid or hydrochloric acid in this case. Okay, so basically what potassium chloride is a salt. So it is formed by the combination of a basic radical, that is potassium, and acid radical, that is chlorine. Clear? Potassium is contributed by the base, so it is a basic radical. Chlorine is contributed by the acid, so it is an acid radical. That way also we can classify the radicals, basic and acidic. Apart from that, we have simple radical and compound radicals. Clear? Or complex radicals. So now let me clear something regarding this acid, base and salt. Actually, you are actually coming across these three words frequently in your chemistry books. But still, I can see the confusion, I can feel the confusion regarding these three concepts, that is acid, base and salt. Okay? And one more thing, I will be asking some questions in between. And I want you all to participate by posting your answers in the comment box so that I come to know that you are actually watching the videos thoroughly. Okay? So I want whatever questions I'll be asking in between this lecture, the answers you should be giving me in the comment box. Clear? And I want to see as many of you participating in giving the answers. Okay? Now, this is the neutralization reaction we have read just now. Now, here three things are involved. You can just see base, acid, salt. So what is this base? Actually, this is not in our topic, but you should be clear about these things because frequently you'll come across in the language of chemistry or whatever chapters of chemistry you're dealing, you're coming across acid, you're coming across base, you're coming across salt. So let's come to the topic, base. The first one is base. Physically, base is something which is having a slippery texture, like your soapy texture. Yes. Apart from that, base is bitter to taste. Okay. And base is usually, like we can say, it is the metal hydroxide. Metal hydroxide or metal oxide, or it's also ammonium hydroxide. All these things come under the category of bases. Bases, usually the metal hydroxides and the metal oxides, they are called as bases. Bases have the power to neutralize what? The acid. Bases have the quality of neutralizing the acid. That's why when a base reacts with acid, it neutralizes the acid and forms salt and water. Neutralization is taking place here. Okay. So now all the elements. Now when I'll be teaching you the periodic table, we'll be more clear about the alkalis, the alkali and the alkaline earth metals, the group 1 and the group 2 elements of the periodic table. There are hydroxides, there are oxides, and apart from that, ammonium hydroxide. So all these are together termed as base. Now what is this acid? So basically hydroxide refers to what? OH minus. Yes or no? And oxide, you know, it is O2 minus. Clear? Now what is an acid? Acid is something which yields H plus ion. Acid is something, a chemical compound that gives H plus ion. But since this H, when it is dissolved in water, in aqueous state, okay? But this H plus ion is basically what? Unstable. It is unstable, so it combines with water to form hydronium ion. It forms what? Hydronium ion. This is called as hydronium ion. So we can say an acid is something which yields what? Hydronium ion. Okay? So this is what is the definition of an acid. So you have learned about the various types of acids like the HCl, H2SO4 is a sulfuric acid, H2CO3 is a carbonic acid, H3PO4 is a phosphoric acid, And then there are many kinds of acids, mineral acids, we have organic acids, we have strong acids, weak acids. So all those, it's itself a very big chapter, okay? Just for the timing, let me just give you a general idea, okay? Then now we have the third one, that is a salt. Salt is a chemical compound that has at least one cation except H plus and one anion except OH minus. This is the basic definition of a salt, and again salt are again classified into various categories, okay? We have normal salt, we have acid salt, we have basic salt, we have complex salt, okay? So many categories are there, double salt, but we will not come into those topics again right now. So just for the timing, you should know that there are three categories of salt: normal salt, acid salt and basic salt. These three things you should know, okay? That means potassium chloride is a salt, I told you. Sodium chloride is a salt you have learned from your lower classes. Clear? Let me write some more salts here. Silver nitrate, okay? So now let us see, take these three examples. Now, potassium chloride is a salt. What is the definition of a salt? It should have one cation other than H plus. Yes, it has one cation, K plus. It should have one anion except OH minus. Yes, it's having one anion. Apart from OH minus, it's having, except OH minus, it is having one Cl minus ion. So it is a salt. The language of chemistry, it is called as a salt. Sodium chloride has one Na plus ion, which is not H plus, and it has one Cl minus ion, which is not OH minus. So it is a salt. It is also a salt. Silver nitrate is a salt because silver is a, in this case, silver is and the Ag plus ion, except the H plus ion here, it's having a cation, it's having an anion called nitrate. So it is also a salt. Clear? And apart from that, as I told you, you have you must have come across the salts like NaHSO4, KHCO3. Now these are also salts. Why? You can see here. It has two it has two cations, Na plus and H plus. So apart from H plus, it also has what? Na plus. It has Na plus, and it has one. It has a anion sulfate except OH minus. So it's also a salt in chemistry. Yes or no? And this type of salt is called as acid salt. Why it is called as acid salt? Because the hydrogen ion is not completely removed, not completely replaced or removed. Okay. What about this potassium bicarbonate? It has K plus ion, which is not H plus. Apart from H plus, it has K plus, and it has also one anion CO3 minus, CO3 2 minus. Yes or no? So it's also a salt. So this type of salt is called as acid salt because here the hydrogen ion is not completely removed. But these are what? Normal salts. These are what? Normal salts. And these are acid salts. Now what about the basic salt? Basic salt like Cu, OH, Cl. Okay, this is called as basic copper chloride. Basic copper chloride because here the hydroxide ion is not completely removed. Here the hydroxide ion is not completely removed. So this is called as basic copper chloride. So this is a basic salt, this is acid salt, and this is a normal salt. So I hope with this some general idea, some general concept about the base, acid and salt which are frequently coming across in chemistry, I think must be getting somewhat clear. Okay. Now my question, the first question for today is, I want you to post your answers in the comment box. Tell me, as per the definition of salt, whether is calcium oxide a salt? Can you call calcium oxide a salt? So I'm expecting a lot of answers from you, and let us see who is able to prove the point. If yes, why? If yes, why not? Okay. Now coming to the next part. So about the radicals, I think your ideas are clear now. We have electropositive radical cation, electronegative radical anion. We have basic radical, which comes from the base. in a salt and from the base, and acid radical which comes from the acid, contributed by the acid in the formation of a salt. So why sodium hydroxide is not a salt? Because it has OH minus. Except OH minus, it doesn't have any other electronegative radical. It has a electropositive radical except H plus, but it doesn't have a electronegative radical except OH minus. So sodium hydroxide is not a salt. Okay. So now let us come to the representation of an element. Representation of an element. So if we go back to the history, before 1600 AD, the alchemist used pictographic symbols. They used what? Pictographic symbols to depict or to represent certain kind of elements or things. Like they used a triangle for earth. For earth they use what? Triangle. And a crescent-like shape for silver. So likewise, this alchemists are none other than the earlier chemist. And alchemy is a science or the medieval forerunner of chemistry. So they tried to represent elements or substances using what? Pictographic symbols. Then around the year 1807, a scientist named John Dalton used what? He used figurative symbols. To depict certain elements. Clear? Like he used O for oxygen, O, and in the center a dot, okay, for hydrogen. For nitrogen he used a symbol like this. For sulfur he used a symbol like this. Okay, so these were the symbols used for oxygen, for hydrogen, for nitrogen, for sulfur. But then, as you can see here, these figurative symbols were not very useful, and it was time consuming as well as confusing. So later on in the year 1814, another scientist named Johann Berzelius, he proposed that let us symbolize these elements based on their English names, using the first letter of their English names. And it was after his proposal, and it was because of his theory that now we have the IUPAC nomenclature of naming the elements. For naming the elements. Now IUPAC stands for International Union of Pure and Applied Chemistry. So as you know, we have been naming elements according to the IUPAC nomenclature, where we either use the first letter of the English alphabet, first or another letter of the English alphabet, okay, and also we use the Latin names. So it was because of the work of Johann Berzelius who proposed this theory, and later on it laid the foundation for the IUPAC nomenclature which we are following now. Chemistry. So chemical symbol means what? It is a short form. It is basically what? The short form. And it represents what? One atom. Now, by now you must be clear what is an atom, what is a molecule, what is a compound. So one atom of an element. Okay? It represents, like if I write N is a short form of nitrogen. You know that it is very tedious or very time-taking process to write down the full name. So we usually write our short names. We call each other with the nicknames. No, short. We just don't want to waste time on this writing the full name of everything. So this practice came along. So now after that IUPAC nomenclature, in the IUPAC nomenclature, so we are writing the short form. That is the chemical symbol. For every element there is a symbol, there is a short form. So instead of writing the full name nitrogen, we simply write N. This N stands for what? It stands for, it is a short form of nitrogen, it stands for one atom of nitrogen. O stands for one atom of oxygen. S stands for one atom of sulfur, right? So what is the significance? What is the significance of a chemical symbol? Okay. Suppose if you are asked to write, what is the significance of P? What is the significance of P? So you just simply write on 3 points for that. It represents phosphorus. P stands for phosphorus. So it represents the element phosphorus. Then the second thing that you come across is it represents one atom of phosphorus. Yes. Third thing that you come across is what? The atomic mass of phosphorus is 31 grams. So you have been asked to learn the atomic number and the atomic masses of the first 20 elements of the periodic table. So you know that the atomic mass of phosphorus expressed in gram is how much? Mass of the atom. It's the mass of the atom. Atomic mass is the mass of the atom. So it is how much? 31 gram. So this is the significance of chemical symbol. Now let us come to the chemical formula. So when two or more elements combine together, we get a compound, a molecule of the compound. And when you represent a compound, it is called as a chemical formula. Chemical formula, with the help of chemical formula, you not only represent compound, but you also represent what? Element. Element as well as compound. Because you know that we have, apart from monoatomic, the inert gases are monoatomic in nature, helium, neon, argon, all these things, they are monoatomic in nature. But like we take the example of H2, N2, Cl2. So these are what? Diatomic. We have triatomic, O3. We have a tetraatomic, P4. We have octaatomic, S8. So likewise we have, so this is what? Basically the atomicity. We call it what? Atomicity. Yes or no? The number of atoms present in one molecule of an element. The number of atoms present in one molecule of an element is called its atomicity. So when I write Cl, simply Cl is one atom of chlorine. But when I write Cl2, it represents what? One molecule of chlorine. Because one atom of chlorine is unstable. So this is only one atom. This is only, so a chemical symbol represents only one atom. But a chemical formula represents what? One molecule. Since Cl cannot exist independently, so it combines with, it enters into covalent bonding with another chlorine. Last class only I had told you. So this is what? One molecule of chlorine. Okay. Likewise for a compound, let us take the example of suppose the chemical formula of a compound. Let us take suppose potassium sulfate, K2SO4. Okay. Potassium sulfate. Clear? So this is what? This is a chemical formula. This represents what? One molecule of potassium sulfate. This represents one molecule of potassium sulfate, where there are two atoms of potassium, one atom of sulfur, and 4 atoms of what? Oxygen. Okay. So chemical formula basically refers to, it represents what? One molecule of a compound or an element. Molecular formula represents one molecule of an element or a compound. Okay. So what is the significance of chemical formula? Let us take magnesium chloride, or suppose let us take ammonia. So this is a chemical formula of one molecule of sodium, one molecule of ammonia, chemical formula of one molecule of ammonia. So what is the significance? the first thing when you come across this formula, the first thing that you understand from this is that it represents one molecule of ammonia. It represents one molecule of what? Ammonia. Second thing, one molecule of ammonia, okay, one molecule of ammonia is made by chemical combination of one atom of nitrogen and 3 atoms of hydrogen. 3 atoms of what? Hydrogen. Clear? So what is the significance of a chemical formula? First thing you come to know about the name of the compound is this, and it represents one molecule of the compound. Secondly, the constituent elements. Okay. Third thing, the molecular mass. And in your 8th standard, you have learned how to calculate the molecular mass. Atomic masses are sometimes given to you respectively. But then 1 to 20, if you remember, it's well and good. And if you remember some of the important elements that you come across, it's good to remember most of them. Okay. So I'm showing you here nitrogen, the atomic is 7 and 14. So atomic mass is 14 plus 1 hydrogen is 1. So 3 hydrogen will be 3. So it's how much? 14 plus 3, 17 gram. Isn't it? You have done this. So the molecular mass of ammonia is 14 gram. Okay, or is 14 gram, where you can write down like that, where the mass of nitrogen taken is 14 and the mass of one hydrogen is 1 and the mass of one hydrogen atom is 1 gram. Okay, so this is the significance of a chemical formula. Okay, now let us come to the next topic. The next topic of today is writing the chemical formula. Okay, writing chemical formula. You have already learned the criss-cross method of writing the chemical formula. And you know it. You have been asked to learn the formula for the various radicals along with their valencies. So before coming into this topic, you should be well aware about the formula of the ions and the radicals along with their valencies. Okay, so that easily you can continue with the process of the criss-cross method. So unless and until you are aware of the valencies, you cannot write the chemical formula of a compound. Okay, suppose the first example, let us take, suppose it is magnesium chloride. Magnesium chloride. Okay, so magnesium chloride. So now the first thing you're asked to do is, always remember the electropositive ion is written first, then the electronegative ion is written. So this is the name of the compound magnesium chloride. First thing, you are asked to write the formula. What is the formula for magnesium? What is the symbol of magnesium? It's Mg. What is the symbol of chloride? It's Cl. Okay. The next thing, you write the respective valencies as the superscript. Okay. That means the valency of magnesium is, it is 2 plus the valency of chlorine is 1 minus. So now just you are shifting it. This is called as a crisscross. Both are simple radicals. The 2 goes here, 1 comes here. So by default, we don't write 1. It's understood it is 1 only. So what is the formula that we obtain? Mg and Cl2. So when you write here, don't write -2. Okay, when you write here, you are not supposed to write -2. So this is the way we write the chemical formula by the criss-cross method. Now let us take some more compounds, like suppose aluminium phosphate. aluminium phosphate. Okay. So before writing it, you should know that the symbol of aluminium is Al. The symbol of phosphate is what? PO4. After you know this only, you can continue with this. So the first and foremost thing is learn all the valencies and the ions and the radicals, whatever is given in your textbooks. Go through it, learn it, and then go for it. Okay. So we know that aluminium's valency is how much? 3 plus. What about the valency of phosphate? It is again 3 minus. Okay. Isn't it? So 3 and this 3. Now, if they are divisible by the highest common factor, you can cancel it. So 3a and 3 cancels out. What is left out? What is left out? It's 1. 1 is left out. So ultimately, what is the formula of aluminium phosphate? AlPO4. AlPO4. Let us take the example one more. Let us try one more. Ammonium sulfate. Okay, third one. Ammonium sulfate. Okay. So both are what? Compound radicals. Ammonium is NH4. Sulfate is SO4. Okay. The valency of ammonium is 1 plus. The valency of sulfate is 2 minus. Okay. Now what is to be done? 2 will come here. 1 will go here. Yes. So now already the formula of ammonium, it's itself a compound radical. So this is the subscript of ammonium. Okay. This 4 will remain there at the bottom itself. Nothing will be done and no changes there at the bottom. So NH4, okay, it will remain there, NH4. Now this 2 is for the entire ammonium ion, so you cannot write. So what you should do, you should put a bracket here. You should put a bracket here. So it is read as NH4 whole 2. NH4 whole 2. And SO4 whole 1 is same as simply SO4. So we write only NH4 whole 2 SO4. So remember one thing, this 2 is for nitrogen as well as hydrogen. So as a whole, we can say that one molecule of ammonium sulfate is composed of 2 atoms of nitrogen. How many atoms of hydrogen here? 4 multiplied to 2, 8 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen. Let us take one last one. Suppose let us take magnesium hydroxide. So magnesium is Mg, the valency is 2 plus, hydroxide is OH, the valency is 1 minus, 1 will shift here, 2 will shift here, yes, 1 and here 2. So now we can say that Mg, 1 is Mg, OH. So for the whole OH, for the whole hydroxide, this 2 is there. So we will write here OH whole 2. Okay, so this 2 is for oxygen as well as for hydrogen. I think the idea is very, very clear for all of you. And also keep on practicing the calculation of atomic masses. Okay. Now, let us immediately come to the next topic. So before that, let me put the second question for you all. The second question is, there is an element M. First question already I have asked you earlier. The second question for today. There is an element M, the formula of whose hydroxide is MOH whole 2. Okay, MOH whole 2. State the valency. State the valency of M. Write the formula. Okay. Write the formula of its thiosulfate, zincate and chromate. Okay, this is the second question for you, and I will see how many of you are able to Give the correct answers for all the questions that I am asking in between. Okay, in the comment box, you will post your answers, right? Formula. Okay, and in the next class, we will be discussing the remaining topics which are left out. I hope and I expect that every one of you will be going through this video well, and whatever questions, the 2 questions that I have put you, you will be answering in the comment box. So eagerly waiting for your answers. That will prove that you are actually going through the video well. And then till the next class, stay safe and study well. Complete all your work.